Hey everyone, welcome to my YouTube channel. In this video, I'll be tackling the longest substring without repeating characters challenge, so let's get into it. The description states that, given a string called s, find the length of the longest substring without repeating characters. So what is a substring? LeetCode defines a substring as a contiguous non-empty sequence of characters within a string. And in simple terms, a substring is just a smaller part of a longer text or sequence created by taking consecutive characters or elements from the original text without skipping any of them. To better understand, let's look at some of these examples. Example 1, input s equals this string containing characters a, b, c, b, b. Our output is an integer called integer number 3. The answer is ABC, right? Because a substring, right, is a smaller part of a longer text in which it makes up of consecutive characters, right? And the answer is 3 because the length of this substring, ABC, is 3. Look at example 2. Input is our string, which contains 5 b's. Our output is the number 1 because the answer is just b, right? Just the character b, or string with the letter b in it, right? And example 3 is our input string is that of pww, kew. Our output is 3, very similar to example 1 because the answer is wke with the length of 3. But the difference is that they state that notice that the answer must be a substring. Pwke is a subsequence and not a substring. So what we know about a substring is that a subsequence is a smaller part of a longer text created by taking non-consecutive characters or elements from the original, right? Because you can see it here with the P in front of this WKE, right? You can see in this original, it said P, okay, cool. Okay, W, awesome, it's not repeating. Oh, here's a repeating one. We gotta drop this W right here, but then, it keeps continuing, but somehow it contains this P still. So we need to figure out a way to not return a subsequence, because then we're going to return the incorrect length, which will fail the test, right? Because this will be a length of 4 and not 3. So before we get started with any optimal solution, I like to start with a brute force approach. So I'm just going to write brute force approach. And the reason why I want to start with the brute force approach is because if you never heard of a brute force approach, it's essentially just checking all possibilities, right? Checking every single combination of characters and possibilities to find the longest substring without any repeating characters, right? And the reason why I want to start with a brute force approach is because it'll help us really get a really good starting point and for our optimal solution, and to also really appreciate the efficiency of our optimized solution, right? So to get started, I'm gonna write some pseudocode here with some comments, right? And the way I go about the pseudocode is to look at our inputs, look at our outputs, look at the explanations, and try to figure out, what exactly do we need, right, to get our all 3 of these tests passing, right? And to start off, our inputs are all strings, obviously within the description, right? However, our outputs are all integers. So my thought process is that we're going to iterate over every single individual character within the string, because again, you can think of a string as an array of characters, right? So within our brute force approach, we're going to iterate through every single character, and we're going to compare them to make sure they're not repeating, and then we're going to have some sort of some counter variables to keep track of the length of these substrings that we're going to be building, right? So let's write counter to track maximum substring length, iteration, right, loop, iteration or loop over input string, and then within our loop, we're going to have to keep track of current characters or cars, and then we're going to have to keep track of current substring length that we're currently building, right? And then I'm going to return maximum substring length. And again, we can always go back, adjust, pivot, add things, remove things, adjust things as need be. We're just trying to get a rough sketch down for how we're going to lay out our code, right? A plan of attack, so to speak, right? So counter to track maximum substring length, which is what we're going to be returning, right? So looking at our output here, it's going to be of type int. So we're going to initialize a variable of type int. I'm gonna call it max length equal to 0. And again, the whole point of this variable is to keep track of the maximum length of the substring, right? Not the current length, but the max length, right? And we initialize it to 0, so we start at the beginning of this input string, right? Because again, we want to you want to view this string, this input string as an array, essentially an array of characters. So iteration or loop over input string. So I'm using a for loop, and if you're not familiar with for loop, you can check out my my 2sums video. I'll have it linked in the description. I really go in depth over what a for loop is and the whole anatomy of the for loop and how it works. And I'm going to move these up into the for loop. All right, so now that we have that all that out of the way, we need to keep track of our current characters, and we need to keep track of the current substring length. So let's start with the keep track of our current characters. So how are we going to keep track of our current characters, right? And like what kind of collection are we going to use to store these current characters that we're iterating through, right? And we're going to be using something called a HashSet. And before we go any further, I'm going to go over what a HashSet is, just because if you've never heard of a HashSet, ever used a HashSet, we're going to go over the definitions from Microsoft documentations. And once we get a solid understanding about what a HashSet is, why we're using it, and the benefits of using it for this particular challenge, then we'll continue. So I already have the Microsoft documentation opened up to the HashSet class definition. And I mean, the definition represents a set of values, which I don't think is extremely helpful in this case to understand why we're using a hash set. So we're going to scroll down to the remarks where they write the hash set class provides high performance set operations. A set is a collection that contains no duplicate elements and whose elements are in no particular order. And this is great because, again, the whole point of this challenge is to return the length of our substring without repeating characters, right? So a hash set will guarantee that we're not having any sort of duplicate elements, right? And even here, whose elements are in no particular order, right? So now we're just returning the length, right? The length of this substring, right? We're not having to return the actual substring. So we don't need to worry about whether or not the substring is in correct order. We just have to worry about whether or not it contains any repeating characters within its consecutive sequence, right? To go a little bit further into the hash definition of a hash set, the hash set class is based on the model of mathematical sets and provides high performance set operations similar to accessing the keys of the dictionary, which we used in the add two numbers challenge that I'll have some floating up somewhere if you want to check it out. Or hash table collections, right? And a model of mathematical sets. A mathematical set is just a collection of different things. In this case will be characters, right? In simple terms, the hash set class can be thought of as a dictionary collection without values, right? So why use a hash set and not a dictionary? Why not use these key value pairs? And that's because, with this challenge in particular, right, we're just trying to track unique elements. We're just trying to track, unique characters, right? We don't want any repeating characters. We're trying to track unique characters. And to me, a hash set is really perfect for this because we don't really need any key value pairs, right? A hash set is going to be the most simple, right, and most efficient, to me, collection for this purpose, right? This challenge in particular. Going down a little bit more, I'm going to scroll down to some of these methods, and I'm going to go to this get hash code method in particular, right? And you might be like, why are we going to this get hash code method? And its definition is serves as the default hash function, right? Why am I talking about this? And that's because, with arrays and lists, right, they are index based, but a hash set and even a dictionary are what you would call a hash-based collection, right? So what is a hash-based collection? And essentially, hash-based collections use hash functions to store and retrieve data, right? And they use a hash function, right, to take an input, in this case, a character, right, and produce a fixed size value, which they call a hash code, right, that represents that input. So looking a little bit further into the Microsoft documentation's really remarks about a hash code, they write a hash code is a numeric value that is used to insert and identify an object in a hash-based collection, right? Such as the dictionary class, the hash table class, or type derived from the dictionary-based class, which our HashSet is included in this, right? Again, insert and identify sounds very familiar to when you're talking about arrays and lists and index, right? Instead of using an index, right, 0 through however long the array is, it's generating or creating this hash code, right? And like we talked about in the add two numbers challenge, right, a dictionary, as well as a hash set, right, is, when iterating through it or trying to search for a particular value within a hash-based collection, is going to be near O of 1, which is a constant time complexity, which is really, really great, right? Really, really optimal, really, really fast, right? Compared to a nested for loop, which is O of n squared, which is not too good, right? So with that, we're going to use our hash set to store our characters. And how we're going to do that is by using this constructor right here, right? Initializes a new instance of the hash set class that is empty and uses the default equality compare for the set type, right? So just like we saw in the docs, we're going to create a variable of type hash set, hash set of type car, call it car set equal to new hash set, because again, we are instantiating a new hash set of type car that we're going to be using to keep track of our current cars that we are going to be iterating through and building our substring out of, right? And keep track of our current substring length, right? We're going to be using another counter, right, to keep track of the current length that we are the current length of the substring that we are building, right? This is just going to return the maximum length, right? The longest length that we could have that we've gotten with a valid substring with no repeating characters. This counter variable is going to be keeping track of the current substring that we're building, right? And whatever its length is, right? We're going to do a comparison whether or not it's greater than, right, or less than this max length, right? And hopefully it'll make a little bit more sense as we continue down. So we need to figure out, right, within this for loop, right, how are we going to build our substring? And we're going to be building it using an inner loop. So an inner loop to build our substring. Well, I'm just going to say inner loop to build substring. And again, for int j equals I, and I'll speak about why we're setting it equal to I instead of having it, set to a particular value like 0 or I plus 1, right? So I actually have a Excalidraw little diagram drawn here. Sorry about the white background. I know it might be a bit jarring from all these black backgrounds, these dark backgrounds from these websites. But here we have our string that I've broken down into an array, or more like into characters, right? And using these hash codes to be to represent these indexes, right? Because I might make a video detailing more about what a hash code is and how it's broken down to be an index whenever it's being searched for, whenever you use that get hash code method. But essentially, right, we have I and j, right, our counter variables for our for loops. We have I equals 0 and j equals I, so they're both at the same starting point. And the reason why we have j equal to I is because say if I, say if I is equal to 0, 1, 2, right? But j is hard-coded to be 0, right? It'll never, you'll never do, you can't essentially trim off what's already been iterated through, right? And this is called the, something called like the sliding door, right? Or sliding window, right? Where you never want to repeat yourself, right? You don't want to repeat the steps, right? Because it kind of defeats the purpose, right? So, for instance, right? Let's go through this. So here's our string, or input string, that I've broken up into characters. Here's our for loops, both I set to 0, j set to I. So if car set contains s at index of j, which would be p, right? And here's our car set, here's our hash set. Add it to our car set, and let's increment our length. So looking at this if statement, right? Does our car set does our car set contain s at j? Our car set is completely empty right now, so no, it does not. So we're going to add it to our car set. We're going to increment our length, and then we're going to use our essentially our inner for loop to again build our substring. So this j is going to move over 1, but our I is going to stay, right? Our I is going to stay. Our I is going to stay at the index of 0, right? And then it's going to repeat the step, right? Does car set contain s at j? No, it doesn't contain a w. So we're going to store it, right? We're going to add it to our hash set, and then we're going to increment our current count, right? Which is 2 right now, right? So on and so forth. But oh wait, look here. Does our car set contain s at j, which is w? Yes, it does. Oh no, so what are we going to do? We're going to have to figure out how to break out of this inner loop, right? That's building our essentially building our substring, right? To where it'll increment I, and then essentially remove all of these, and then reset our current count on our length counter variable, right? So how are we going to do that? How are we going to do that with this, right? So essentially we want to ask ourselves, does our hash set contain, right? Does it contain the character at j, right? So does it, well, I'm going to say, does hash set contain car? Stop building, right? So how do we do that? We're going to do that with an if statement, right? If car set contains our character at the j index, then we need to stop building. And with the for loop, an easy way to terminate a for loop or jump out of a for loop is using the break keyword, right? The break keyword is essentially going to terminate our inner for loop, or our inner loop. It's going to kick us up back to this outer for loop. It's going to increment this I to 1, and then it's going to reinstantiate our hash set, which is going to remove any sort of characters that we stored when we were building, right? And it's going to reinitialize our length variable to be 0, right? So now we're starting with a brand new hash set, and we're starting back at 0, right? And this is going to repeat, right? And so we build our substring. So that's if we, if our hash set contains a dupe, if our hash set already contains that character. So if not, right, if it doesn't exist in our hash set, then if not, then add it, right? So how do we add it? We're going to use, it's very simple. We're going to use the add method, and we're going to add s at j. Don't forget your semicolon. And then we need to increment our current substring length. And we're going to do that by doing length plus plus. And don't forget the colon. Actually, I'll just, if not, add it. Cool. So, so what we need to think about is this now, right? So, for instance, we've gone through every character. We've built our substring. We have the correct length, right? So now we need to focus on our max length variable up here. And how are we going to do our comparison about whether max length is bigger or larger, or if our current substring length tracker is larger? And we're going to be doing that. Compare if maximum is greater than current substring length. Compare if maximum length is greater than, and we're going to be doing that by reassigning a value of our max length using the math class max method, right? And setting our first parameter to that of the max length and the second one to that of the length. And if you're confused, I have the definition open of the math classes max method. And essentially it takes in two integer parameters, value 1, value 2, and it returns parameter value 1 or value 2 depending on whichever is larger, right? And why do we want to do this, right? And that's because we want to ensure that our max length, right, holds the maximum length found so far, right? Which is going to be representative of our length variable right here, right? And if this length variable obviously is greater than the current max length variable, which is going to be accurate for all three of these cases, right? Then we want to ensure that we update our maximum length to that of the new value, right? Of whatever this length value is, right? And this will ensure that we always have, either 0 or the maximum length, right? And again, we just want to return our maximum substring length. So return max length, semicolon, right? So we'll try to run it and see what we get. Cool. So look at that. All of our cases have passed. Now, obviously, this brute force approach works, but it's obviously not the most efficient solution, right? So I'm going to remove these. And we're going to talk about the optimized approach, right? In a very similar fashion, I'll be writing down notes and stuff like that. So what's the optimized approach, right? To really improve our performance of where we started, right? We want to utilize something called the two-pointer technique, right? Or the two-pointer method to really avoid any sort of redundant checks and to make our solution just overall more efficient, right? So what is the two-pointer solution, right? What is this two-pointer technique? My apologies. So I actually have a handy-dandy demonstration or drawing here, very similar to what I had up earlier, where we have these two pointers, which if you're not familiar with pointers, I talk about them in pretty good detail on the add two numbers challenge, LeetCode challenge that I'll have linked in the description as well. And essentially, we're going to be using these two pointers to traverse our string, right? And this technique is really useful for solving problems that involve finding subarrays or substrings that meet specific criteria. And obviously in our case, we use these two pointers to manage the current substring and efficiently adjust the starting position when repeating character is encountered, right? Because we don't want to be doing any sort of redundant checks, right? So let's look at this drawing, right? So we have our max length equal to 0. We have our input string broken down into characters. We have our start and our end pointers, and we have these two conditionals, right? If this, else that, right? So let's go through it, right? So if HashSet doesn't contain the character at the end index, or our end pointer, right? Then we're going to add the character to our hash set. We're going to increment the end pointer, and then we're going to perform our max math. But instead of having the length variable, we're going to be comparing the max length with the equation of whatever the end pointer's value is minus the start values. And it'll make sense in a little bit about why we're doing this. So let's just do it, right? So does the car set contain this character? No? Well, then we're going to add it to our car set. We're going to, step 2 is to increment our end. So we're going to increment it 1. So it went from being at the 0th index to the first index. And then we're going to do Math.Max, right? We're going to compare whether or not our max length value, which is currently 0, is greater than, right, our end minus our start pointers values, right? So max length is 0. End minus start, 1 minus 0 is 1. So obviously, again, max math, our math method is going to, return the larger value. So our max length is now going to equal that of 1, right? Cool, let's repeat this. So does our car set contain W? No, it just contains the letter P, or character P. So we're going to take this character W, and we're going to add it to our car set. We're going to increment it 1 to the right, and then we're going to show it here numerically. And then again, we're going to do this Math.Max, right? We're going to say, okay, is 2 minus 0, 2. So is 2 greater than 1? Yes, so now our max math is going to equal to 2. Uh-oh, right? Does a car set contain S at end? Yes, it does. So what do we got to do? Remove it, okay? Remove S at start. So we're going to remove this P, right? Because, again, we want to avoid any sort of subsequence, right? We want to essentially treat this remove at S start as a trim, like we're trimming off the bits that, we're trimming the bits off at the leftmost part of this string so that we don't repeat ourselves. And then we're going to do start plus plus. So we're going to increment start 1. So we're going to move it to the right 1. Right? Then again, it's going to say if car set doesn't contain S at end. Oh, it does. So we're going to remove S at start. Right? So this is just going to repeat itself, right? And so essentially it's going to come out very similar to the brute force approach, but in a more elegant and a more proficient and efficient way, right? So let's look at this, right? So like we mentioned before, a 2-pointer approach, we're going to create 2 pointers. We want to create our max length, our maximum substring length counter. We want to, again, have somewhere to store it with our hash set, right? So keep track of current characters, right? And then we want to do some sort of iteration, right? Or iterate loop over our input string. And then I'm just going to write some what we're going to do inside of this this iteration, and that is if car doesn't exist, add it. Well, I'm just going to add it underneath them, right? Add it. And then we're going to increment our end pointer, or increment end pointer. And then we're going to update maximum substring length. If car does exist, remove it from HashSet, and then increment start pointer. And I want to write trim input string, right? And then the very last thing we're going to do is, again, return maximum substring length, right? So let's create our 2 pointers, right? So type int start equals 0, int end. You can call it left, you can call it right, you can call it L, call it R, whatever you want to call it. But to me, start and end is pretty straightforward right here for this particular problem. Create maximum substring length counter. We've already done that in our brute force approach, right? So max length equals 0. A lot of this stuff's going to be very, very familiar to our brute force approach. Keep track of recurrent cars. You already know how to do that, right? Creating a variable called car set of type HashSet type car and instantiate it using the new keyword don't forget the semicolons and these little parentheses over here. And then we're going to iterate or loop over our input string, right? So we're not going to be using a for loop, right? We're going to be using a while loop, right? While, you know, and we're going to be making sure while the value of our end pointer is less than the string's length. And I'm going to move these up here, and I'm going to adjust these, make it easier to read. So while end is less than the length of the input string, right? If our car doesn't exist, right? If this character doesn't exist within our hash set here, right? If it doesn't exist, then we need to add it, right? So if, right? Very similar to what we did with the brute force approach. Right, we did car set contains, but now we're putting the not logical operator in front of it to essentially get the reverse, right? If we write just car set contains s at end, right? This is saying if it contains it, right? But we're trying to verify whether or not if it doesn't exist within it, so we need to use the not operator in front. We need to add it, which should be very familiar at this point. Car set dot add, char set, however you want to say it, right? And then we need to increment our end pointer and plus plus semicolon, and then update our maximum substring layout length. Very similar to what we've done again with our brute force approach, right? Using the Math.Max, and then max length, or the end pointer minus the start pointer, right? And else, again, I'm going to move these up here. If car does exist, right, then we need to remove from the hash set. Very similar to the add, right? The hash set has the remove method s at, and don't forget, it has to be s at start, so that we're not. So the reason why we're doing s at start is so that we're not returning a subsequence, because again, like the p is being returned here, right? Which again, this is not in consecutive. It's not in substring is again in a consecutive sequence. A subsequence is not in a consecutive sequence. So if I didn't do at the start, right, it wouldn't trim off this p. It would still contain the p within the final hash set here, right? And I'm gonna write that. I'm gonna write at start pointer index. Oh, that's kind of confusing. At start to trim the beginning. At start. Well, yeah, I'm gonna say at the index of start, so we do not return subsequence. And then increment our start pointer so that we don't double check ourselves, essentially. and then we return our max length. So with all that craziness, let's try it out. Let's see if I forgot a semicolon. Oh, I did it. All cases are accepted. So after all that, I really hope you understood about, with our brute force approach, why we did what we did, what we did. Hopefully you have a better understanding what a hash set is, that you understand that there are hash-based collections out there. The utilization of using Math.Max to compare two values and return the largest value, and hopefully get a better understanding on how to use the two-pointer technique within an algorithm. So I hope this really helped. Leave a like, subscribe, leave some comments down below about anything that you learned or something that maybe you came up with to solve this particular challenge. And I'll see you in the next one.